Find f if f double prime of x equals 12x squared plus 6x minus 4, and f of 0 equals 4, and f of 1 equal 1. So we have a couple of different values, and we've got a second derivative. So we're going to need to figure out an antiderivative a couple of different times. If we start with the second derivative, if we find an antiderivative, then that will leave us the first derivative. So let's go there first. Looking at x squared, I would need one higher power. That would be an x to the third. The 3 would have come out in front. Well, then I'm going to put a 4 there because I need to end up with 12. You could also think of this as there was a 12 out in front, and then you need to multiply by the reciprocal of the power, which was 1/3. And either way, we end up then with a 4. And we could check it quickly and get that 12x squared back. Plus, so this x would have been one higher power. When the 2 came out in front, I ended up with a 6, so that'll leave me a 3. And again, you could say the 6 is there, reciprocal of the power is 1/2, and then we'd get the 3. And then we'd have minus 4x, because we know the derivative of minus 4x would give us minus 4. And then we have plus constant, and I'm going to call it C1 because we're going to have a couple of different constants in this problem. Now, I look at that and I don't have, sometimes for these initial values or these conditions, they give us a derivative at a certain value, but they didn't here. They just gave us two function values. So let's leave that C1 in there and let's do an antiderivative again. This time I will have the function itself. So this would have been one higher power, and oh, that's where that 4 came from. So we're good on that term because that derivative is indeed this term. Now, oh, same thing here. This is going to be one higher power, and that's where that 3 came from. Looking at this one, I have a negative 2x squared because the 2 coming out in front will multiply with this 2, or negative 2, and get us the negative 4x. Then the C1x must have been an x on it because the derivative of C1x is C1. And then I'm going to have another arbitrary constant on the end because I could have had any kind of a constant there and the derivative of that would have been 0. Now we are ready to look at finding the C1 and C2 based on these two initial conditions. We have the function at 0, so putting in a 0. Needs to equal 4. Well, you can see that all of these other terms end up being 0, so that tells us C2 is 4. So we could put a 4 right here for C2. Now we need to evaluate the function at 1. And so that's going to be 1 to the 4th plus 1 to the 3rd minus 2 times 1 to the 2nd plus C1 times 1 plus 4, because I went ahead and put in what we found C2 was. And that needs to equal 1. Well, let's simplify. Here's 1 plus 1 minus 2, so those are gone. And so it looks like C1 plus 4 equals 1, so C1 must be negative 3. Now we're ready to find our function then. It's just the function we had, but putting in the constants that we found. So it's x to the 4th plus x to the 3rd minus 2x to the 2nd minus 3x plus 4. And we could take a quick derivative of that, 2 of those in fact, to make sure we ended up here. And we could also make sure, I mean, that's how we found those constant, but that if we evaluate it at 0, we get 4, which we do, and if we evaluate it at 1, we get 1, which we do.